Hi everyone. After topic 10, we move to topic 14. Other topics in between are trig functions and we don't do them. So, before I start, I want to just talk about this page. Okay, so topics of algebra, logarithm, trigs, and so they answer many questions in mathematics. So they are fundamental. So important fundamental that they answer many questions for us. But there are other questions that we need calculus to answer. So by calculus, I mean deep understanding on functions and limits and derivative, integral, application of derivative, application of integral. Before we just go to those topics, so we want to see this. Okay, average speed. If you remember, average speed is distance, the difference on distance over difference on time. So if I have the distance graph like this, the average speed is so velocity average is d2 minus d1 over t2 minus t1. Okay, distance on d over distance on d over distance on t. So it looks like a slope. A slope of which line? A slope of this line that connects these 2 points. So 1 point here and 1 point here. Okay, so let me see if I can draw it this way. Okay, no. So I just use maybe this. Okay, see, I have a line, this here, this connects these 2 points, and a slope of these 2 points, a slope of this line is change on y, which is d2 minus d1, or change on distance over change on time, like change on x, which is here is t2 minus t1. Okay, average speed. So means the amount of distance changed from over the amount of time changed. Okay, so for example in 1 hour the distance changed this amount, and then I can find average speed. So it doesn't mean at each moment my speed was that. No, this is average over this time. Okay, so I can define second line and then relate this to second line. Second line is when I have a curve and I have, for example, a line which connects 2 points on the curve, I call it a second line. So each curve has many second line because when I change 2 points, the second line is going to change. Okay, so so I can relate this to get to each other. So I can say like average speed here, for example, for this average speed, which is distance change on d over change on t, is like a slope of this second line, and second line is a line which connects 2 points on the curve. Okay, so let's do this example. A trip is taken in which you drive 150 kilometers in 3 hours. Means change on distance is 150 kilometers. I don't know where we started and where we end. No, we just know the change. Okay, the entire change is 150 kilometers and the entire change on time is 3 hours. So it is 50 kilometers per hour. That's the average speed. So maybe the speed at each moment is not that, but this is the average speed. Okay, so now I can do several examples like this. Okay, and I can emphasize here again, if I have the curve of distance or just based on time, okay, distance on y-axis and time on x-axis, okay, average speed is like a slope of second line which connects 2 points. Okay, so now I can continue here. Okay, dt is 2t plus 1 is a function which describes a motion of an object as it moves along a straight line. T is time. Okay? So, the distance is meters and T is second. So, what is average speed from 2 seconds to 4 seconds? So, do you remember this? So, average speed is velocity average is velocity average is d4 minus d2. Okay, so just average speed, so maybe I can just write average speed or velocity average. So d4 minus d2, okay, over t4 over 4 minus 2, okay, which is d4, you sub in 4 minus d2 divided by 4 minus 2. Okay, so look at here on the graph. See, this is, for example, t1 and this is t2. Okay, so delta t in mathematics changes. I show delta t is t2 minus t1. Okay, so for t1 I have d t1, which is here d t1, and for t2 I have d t2, and then I find the answer. So here is d t2 minus d t1. Maybe d2 and d1 are given to me as value, or maybe I have the function I have to substitute to find the answer, like this example. Oh, okay, so here I have to find the answer. 2 multiple 4 plus 1 minus 2 multiple 2 plus 1 divided by 4 minus 2, which is 9 minus 5 over 2, which is 4 over 2, which is 2 meter per second. Why? Because I know the unit is meter. So I either have d2, which is the second d, and I have d1, or I have to calculate it. This is d2, which is d for 4 seconds, and this is d1, which is d for 2 seconds. In the denominator I have t2 minus t1, which is 4 minus 2. Okay, and I can calculate. So yes, right now I saw this on the graph that this is like a slope of second line, and also I did it with example. For this question you had the change, you didn't know d2 d1 t2 t1, you just know the change on top, change on bottom, and here you know t1 and t2, and you have to calculate d1 and d2 and then calculate the answer. So find the average speed of given function for different t's. Okay, so the average speed here is d4 minus d3 divided by 4 minus 3. What is d4? Okay, 5 multiple 4 squared plus 6 minus 5 multiple 3 squared plus 6 divided by 1. Okay, meter per second. Okay, the result is 5 multiple 16, 80 plus 6. Yes, it is 86 minus 51 divided by 1. Yes, which is 35 meter per second. Okay, so average speed d2 minus d1 divided by t2 minus t1. d2 is dt1 and d1 is dt1. Okay, so which is here I said, and also here. Okay, so now you do this one for this. Okay, so D3 minus D2 divided by 3 minus 2. What is D3? So 2 multiple 9, 18. Okay. Am I right? So 2 multiple 3 squared, which is 9, minus 5. Okay, so 13 minus 2 multiple 2 squared, which is 8 minus 5, so 3. Okay, so this. So this is 10 meter per second. How about here? So the same. D5 minus D2 divided by 5 minus 2 meter per second. You can calculate it. How about the next? Yes, so the same thing. So I have D9 minus D5 over 9 minus 5 meter per second. That's for the same question, meter per second. Okay, a charged particle, for the next question, moves from this meter to this meter from a fixed reference point in 0.50 microsecond. Okay, find the average speed during the travel in a nanosecond. Okay, see, this is delta t, this is delta t, this is change on t. Okay, oh, okay, so it is this meter minus this meter. I show you the units because I want you to see both of them are meter. Okay, so we have to be careful. And then divided by this microsecond. I want to go to meter per nanosecond. Okay, so multiple. Microsecond is 10 power minus second. Okay, so we use Math 171 conversion. So I want to cancel microsecond. I write microsecond up, and I want to bring second. I write this down. Multiple. Nanosecond is 10 power minus 9 second. Then I can cancel this and this. I can cancel this and this. And what is left is this one and this one and this one and this one and this one. So calculate it. So it is 0.30 multiple 10 power minus 3 meter per nanosecond. Okay, so be careful with the units. Maybe we do conversion. Maybe we need conversions. Okay, so an electron moves. So move the. Let me see if I can. Yeah, and zoom in and nothing happened here. Okay, yes. Okay, an electron moved a distance of this millimeter in this. So means I have delta D over delta T. Delta means change in mathematics. So that's a symbol for change. For example, you want to write it in the quiz or test, you can just write delta. Okay, so that's delta. We understand it. Okay, so find the average speed meter per second. Okay, so delta D over delta T is 0.25 millimeter over 1.0 microsecond multiple. I want to cancel millimeter and I want to bring meter. Millimeter is up, I want to cancel. So I write millimeter down, 10 power minus 3 meter up. Then multiple. Microsecond, I want to cancel and bring second. So it is 10 power. Yes, it is 10 power. Let me see. Yes, 10 power minus 6 second. Okay, so now I cancel. I cancel this and this. I cancel this and this. What is left? This one and this one and this one and this one, which is 250. When I calculate, 250 meter per second. Okay, so far so good. I had the change on D over the change on T, or I have D2 minus D1 over T1 minus T2 minus T1, or I have DT2 minus DT1 over T2 minus T1. Okay, how about if I want to do for this question? Okay, suppose a ball is dropped from CN Tower, okay, from this distance. Okay, how fast is the ball falling at 3 seconds? How fast? So you would say, okay, so 3 seconds, okay, is here, for example, here. Oh, okay, so yes, I learned it's asking for a speed on 3 seconds. So I would do this. Okay, D at 3 minus D at this 3 divided by 3 minus 3. So far I learned that. But then I see it is 0 over 0. Oh my goodness. 0 over 0 is not 1. 0 over 0 is not defined. So it's not clear. In mathematics we say that's not defined. If I have exactly 0 over 0, that's not defined. Okay? So I have 0 over 0, that's not defined. If I have in limit, I say that's not clear, and I have to make it clear. So we will see limit in future, okay, in the next lesson. So we cannot do that. Now what can I do? I would say, okay, I couldn't do this, but I know if I have 2 points, the same as average speed, I can do it. I say, okay, so instead of 3 and 3, use 3.1 and 3. Oh, okay, so a point closer to that. Look at this, a point close to 3. Oh, okay, I can do it. Yes, so this is the formula. Okay, 4.9 multiple 3.1 squared minus 4.9 multiple 3 squared divided by 0.1, because that's the average change on T. Okay, this is 29.89 meter per second. You would say that's not bad, but it's 3.1. You didn't use 3. I say, okay, how about I go closer? So instead of 3, I use 3.01. How about I do that? You say, okay, so let's see. So it is 4.9 multiple 3.01 squared minus 4.9 multiple 3 squared divided by 0.01, which is, when you calculate, it's 29.449 meter per second. Then you would say, but that's not 3. I would say, okay, what can I do? I go closer. I tell you, okay, I go closer. I try my best. Okay, so it is 4.9 multiple 3.000, okay, 001 squared minus 4.9 multiple this squared divided by this. And then you would say it is 29.4049 meter per second. Okay, I see the first one is 29.89, the second 29.449, and the other one 29.4049 meter per second. Then you would say still it's not 3. I say, okay, so the shorter the period, so the shorter, see here, I go closer and closer. I see the average speed is this. So again, I go closer, I continue. 3.0001, 3.000001. Do you know what I mean? So I go closer. Now you would tell me, okay, yes, you found the answer. This is a speed at that moment, but we had a lot of trouble to find it. It was very hard to find it. What can I do? I don't want to go through all of these. I don't want to say, okay, I need to start from 3.1 and then 3.01 and then 3.001 and then continue closer and closer and closer. Okay, how can I do that? To do this faster. Okay, so see my question. How can we find this value easily? What do we, and why do we need it? Okay, what's the reason we need it and how can we find it? Okay, so I say, okay, before I tell you why you need this value, okay, let's talk about tangent line. Do you remember secant line? So secant line I can show you here. So maybe I can zoom out a little bit. Yes, see, secant line is this here. When I have 2 points on the curve and I connect them, that's secant line. Okay, so I can show secant line here as well. Oh, okay, if I have these 2 points and I connect them, this is secant line. That's secant line. When I have 2 points on the curve and I connect them and I make a line, that's secant line. But then I say, how about if I just make a line that touches the graph just in 1 point, only 1 point? Okay, what can I say to that line? So that line is tangent line. A tangent line is a point that touches the graph just in 1 point, not 2 points. Oh, okay, secant line 2 points, tangent line just 1 point. Okay, yes, which we saw it here. How do we find a slope of secant line? Oh, a slope of secant line. Oh yes, I know how to find it. For example, if this line is Q, for example, if this is Q, then I can say, okay, for example, I can say this is Y equal Fx, okay? So this is, for example, and this one is A and Fa, and this one is B and Fb, for example. These 2 points, and we know each point is a pair of x and y. Okay, so that's here. And then I say, okay, so how can I find a slope of secant line? Oh, you say, okay, I have 2 points on the line. Where is it? I have 2 points on the line. Look, I have 2 points on the line, P and Q. P and Q on the line. Oh, okay, so maybe I can graph it very well. Okay, yeah, so okay, so how can I do that? Oh, okay, I do FB minus FA divided by B minus A for the second line. Yes, I remember this from last semester. I know it. But how about for tangent line? How about for tangent line? Oh, for tangent line, I just have 1 point on the graph. Yes, I can find another point on the line, okay, but this is not on the graph, so I don't have x and y for that point. I don't have x and y for that point. I don't know it. X and y for this point, I don't know. Oh, okay, so what can I do? I just have 1 point which I know. I just have A and FA which I know. Everything else on the red line, I don't know. What should I do? Then I would say, okay, so how about if I do FA minus FA over A minus A? Oh, this is 0 over 0. No, that's not defined. So the reason I need to know this lesson is, and I need to know how can I find this value easily, is a slope of tangent line. So tangent line is a line which touches the graph on 1 point, just at 1 point. So I have just coordinate of 1 point, not 2 points. If I want to find a slope of tangent line, I have trouble. I would say, okay, let's look at this graph. Let's look at this graph. Okay, this graph is okay, so this graph is y equal fx. Okay, yes, I know, and I want a slope of the blue line, which touches the graph just at P, which is 1 and f1. Okay, so if I say a slope of the blue line is f1, if I say, okay, slope of the blue line is f1 minus f1 over 1 minus 1, that's not defined. Okay, so yes, I talked about that. So how about if I talk about another point, which is 2 and f2, look at this, 2 and f2, and instead of blue line I make a green line, which is second line. Okay, blue line is tangent line, that's second line. Then I would say, okay, I found a slope of second line, a slope of the green line. Okay, a slope of the green line is f2 minus f1 divided by 2 minus 1. Then I say, then you would tell me, okay, but you didn't solve the problem because I need the blue one. I say, okay, how about if I take my points as 2, I start and move it to 1. So means I go closer to 1. When I do that, my point on y go closer and closer to f1. f2 goes closer to f1. So then this point goes closer to this green line goes closer to this blue line. Okay, so when I start from 2 and I go closer and closer to 1 on here on x, yes, I go closer and closer on y-axis, and then this green line goes closer to blue line. And then I can say, okay, the slope of the green line is going closer and closer to blue line. Okay, so means I need to start from somewhere and go closer and closer. Read this, okay, I need to start from one point and go closer and closer. So what does this mean? Okay, this means, okay, then you would tell me, okay, you started from 2. What about another point? What's the reason you just used 2? Okay, see here I use 2. I say, okay, I want a slope of the blue line. A slope of the blue line is f1 minus f1 over 1 minus 1. Yes, this is here. This is not defined. So I start from 2 and I go from 2, I go closer to 1 on x-axis. So on y-axis I go closer, green line goes to blue line, and the slope of green line goes to a slope of blue line. Then I have the answer. Then you would tell me, how about 3? Why you didn't start from 3? But then I tell you, okay, I do start from 3. Then you say, why you didn't start from 4? So I tell you, how about we don't start from a specific point, we just start from x. Okay, so I have this blue line, which is tangent line. Okay, this is my graph. So the red one is my graph. The blue line is tangent line, touches the graph in one point, which is P. So if I want to find a slope of the blue line, I have to do f1 minus f1. So f1 minus f1 divided by 1 minus 1, I can't. Okay, so 0 over 0 divided by 0, that's not defined. I would say, okay, I start from just another point. Okay, means I start from x. Oh, okay, so I start from x. I don't say what is x. I don't tell you what is x, because if I say 2, you say how about 3? If I say 3, how about 4? How about 5? Okay, so I don't start from a specific point. Okay, so I start from fx, and then okay, then I have another line, which is the green line. Okay, look at this. For example, maybe this is x here. Okay, so fx minus f1 over x minus 1. Then what did I say? I said I move x to 1. Okay, I told you I move x to 1. Okay, so I move x to 1. Okay, and then I find the answer. This is limit. So if I start from somewhere and I move my point towards another point, for example, I start from something very close, I start from x very close and move toward 1. Okay, let's just show it here. See, I have a red graph. Then I have blue line, which is tangent line. If I want to find a slope of tangent line, it's here, which I don't know. Okay, so I start from, for example, I start from x here. Okay, I start from x. This is fx. This is fx. Okay, and this is another line. Okay, so which maybe I can use black. Okay, so this is another line. Okay, so which connects this point P and connect this point Q. Okay, so then I would say, okay, I start to move x to 1. I start to move x towards 1. When I do that, I start to move fx to f of 1. This is f of 1. Oh, this one also goes towards that. Okay, here. When I do that, then this black line goes through the blue line. And then if I find a stop of black line, okay, I can say, okay, I have a stop of the blue line. So that's why I need to know limit. So what is the limit? When x goes up, when x approaches to 1. Okay, instead of x, I can say I use 1 plus d, because I want at 1. So instead of 1, I use 1 plus d, means I use a little bit close to 1. So 1 plus d, and then I say d approaches to 0. Okay, so see, I say I start from x, fx minus f1 divided by x minus 1 is a slope of second line which connects x and fx to 1 and f1. Then you tell me, okay, but you have to go toward 1. I say yes, I go limit x approaches to 1, and I find the answer. When I find the answer here as limit, this is a slope of tangent line. That's why you need to know the descent. That's why you need to know limit. Equal. Then you say, okay, how about if some books they show this way. They say instead of fx, I say f plus 1d, 1 plus d. 1 plus d means a little bit close to 1, just a little bit. 1 plus d. Okay, minus f1 divided by 1 plus d minus 1. Okay, which is just d. D approaches to 0. Instead of 1, I start from a little bit close to 1, and I find a stop of second line, but then I approach d to 0. When I approach d to 0, then I can say, if I find the answer, I can say this is a stop of tangent line. This is a stop of the blue line. Okay, so here, when I start from x and I move x to 1, then fx also goes to f1. Okay, and then this, for example, if I do x as just the green line, okay, then this one also goes to that line, and then I have the answer for the slope of tangent line. So that's why I need to teach you topic 15, which is limit. You need to know limit, because you cannot find a slope of tangent line without limit. And then in future, I will teach you derivative, and I tell you derivative is related to a slope of tangent line. And it will be much faster and much easier when you know derivative of a function. Okay? So, right now, I need to know a slope of, right now I understand tangent line. What is a slope of tangent line? I understand I cannot find it unless I know limit, unless I start from something close and I go closer and closer. I start from second line and I go closer and closer. Okay, I go closer and closer. Let me show you here. See, when I go closer from 2 to 1, and I go close on, also I go close on one y-axis. Okay, I go close on y-axis, then I can say the green line goes through blue line, and I have the answer. Okay, so in this case I need to know limit, because I need to go closer and closer. I need to approach. Okay, so we need limit because we want to find a slope of tangent line. In future, we talk about derivative, and we relate derivative to a slope of tangent line. which is very fast. Thank you so much. I go to topic 15.